Hello and welcome.
Arc measure and arc length.
Yeah. A central angle is an angle that has a vertex like this, where the vertex is exactly in the center of the circle. The measure of an arc, that is this part here. That's what we're going to look at first. The measure of an arc. And the measure of an arc of a circle is always equal to the measure of its central angle. So what that means is that if this angle here is 70 degrees, then this measure of this arc is also 70 degrees. We know that the inside of the circle, if we were to go all the way around, that would be 360 degrees all the way around. Same thing with the measure of arcs. If you went all the way around the circle, it's 360 total degrees. So this part is 70 because it's exactly the same as what the central angle is. The measure of an arc is always in degrees. We're not looking at length, we're looking at degrees. So the circle size might be different, but we can always tell the measure of how many degrees, thinking of it like as a fraction or as a percentage of the whole circle. So this part here that I just drew in red, from P to R, this would be called a minor arc because it is less than 180 degrees. So we would say its measure is less than 180 degrees. And we'd always use two letters to signify that. So we'd say the measure of arc PR. And we know that that is 70 degrees right now. Right? Now a major arc is the part that's more than 180 degrees. The major arc is this part from P all the way around here to R. But when you say a major arc, you need another point for it to go through to be able to notate that. So let's call this point, I don't know, Q. So we would say the measure of a major arc, the measure is more than 180 degrees. And we would always use three letters for that. We would say the measure, oh, that's a really weird M. The measure of this major arc, P through Q, all the way to R. That tells us that we're not just going the short way, we're going the long way around. And this, we could figure out that measure as well. There's 360 total. 360 minus 70 would leave me 290 degrees to go the whole way around. Which means that this central angle here that went all the way around there is also 290 degrees. That together would make 360 if we finish the circle. So minor arcs are less than 180, major arcs are greater than 180. A semicircle would be equal to 180. So if we had, let's say, another point here, I don't know, point A, then we would say that arc AR is 180. And really it could go this way or this way, and we wouldn't really care because it's 180 either way. Okay. Let's look at arc length. Arc length is not measured in degrees, it's a distance. So we're not just talking about what fraction of the circle or what percent of the circle. Now we're talking about if I had a little string and I took that string from here to here, okay, how big would that string be if I measured it? So let's look at a problem like this, where we have the center, we have the radius here, we've got a point R over here, and this is what we have. So the first thing is let's find the circumference of the circle. We know the circumference is 2 pi r. So in this case, it's going to be 2 times pi times 32. Do we have the circumference? Could you do 2 times pi times 32 on the calculator?
201.06.
Okay, let's go approximately 201. It's not exactly equal to, but the circumference all the way around, if I took a string that made it all the way around and then I stretched it all out, it would measure about 201 total inches. Let's put inches in there. What I am interested in finding out is, let's say I had a point like this. And we'll put Q, point Q here. If I wanted to say, okay, what would be the length, the arc length from Q to R? How long would that string be? How long would I need to cut it so that it would wrap on this circle and it would fit? Okay, so the way to think about this is I just created, if I did this, I just created a 90-degree angle, right? Which means we know from the last screen that this is also 90 degrees. The measure is 90 degrees. So we can get the fraction of the whole. What part of the whole circle is this? This is 90 out of 360, which is really 1/4, or 0.25 if you want to do percent. Okay, so it's really 1/4 of the whole circumference. So if I wanted to find the arc length, I could find, I need to take the whole circumference times like the fraction or the percent that this part is out of the whole. So in this problem, I'm going to take 201 times the fraction that this is, which is 90 out of 360. So if you could take 201 times 0.25 on the calculator, that would give me the part of the circumference that's this part. If you just do make this 0.25, because that's 1/4, times 201, what do we get?
50.25.
All right, 50.25. And I should probably make them squiggles because it's not exactly. And that is inches. That is the length. That is called the arc length from Q to R. That's how long that string would need to be able to reach that far. It's a fraction, it's 1/4 of the whole thing. So anytime you have it, no matter what it is, set it up over 360 and then take that times the whole circumference, and that will give you the length of that arc length. Let's try an example. Find the length of JL. So we're looking right now for the minor arc. We'll do this from J to L. Pause the video and see if you can do this and see if you can get it right. And then restart it for the answer. And go. Okay, so we know this is 109. That's the central angle, which means this is 109. Oh wait, I need to know I have a mistake here. I need to know the radius here. I left off a key part of the information. That's going to mess up the whole video. So let's say that the radius is 7. First, let's find the circumference. That is 2 times pi times r. So calculator friend, 14 times pi.
43.98.
43.98. Okay. Now I know that's my circumference. That would be all the way around. But for the blue part, I'm not going all the way around. I'm only going part way around. So I'm going to take, to find the length of, length, T-H, oh geez, I can't spell, L-E-N-G-T-H, length of JL, I'm going to find the circumference times the fraction of the whole. It's 109 divided by 360. So on the calculator, let's take 109 divided by 360, 0.3, times 43.98.
13.19.
And there is the length of the arc. The measure of the arc is 109 degrees. The length of the arc is 13.19. Have a great day.